So I have already recorded chapter 7, but have not posted it yet. I'll be doing it maybe in the noon. Yeah, and I will send you an email to everyone. Okay. So chapter 7 was all about estimation of population proportion and mean using the confidence interval and also the sample size. So this was about chapter 7. So in your lab 7, question. And I have already posted your midterm grades, and you can find that in your sale account. So chapter 7 was to find out or estimate the confidence interval. So you will be given variables. So part 1, as you can see, it is only for categorical, and part 2 is only for continuous variables. Okay. Now the third question will ask you that whether a confidence interval is valid or not. So how do you check whether it is valid or not? So for continuous variables, if you can read this line in question number 3, the last 2 lines, it says that for categorical variables, you need at least 5 success, and for continuous variables, you need a sample size greater than 30, or you have to check the normality. So continuous variable, it is quite easy to do. You just have to check the sample size. You have, when you plot a histogram, I guess under frequency, you will have capital N. Okay. So if that is greater than 30, you can straight away write that it is valid. If it is not valid, then N will be less than 30. Okay, that is for continuous variables. So for categorical variables, you need at least 5 success. That means N into P, small n and P should be greater than or equal to 5. So I don't want you to calculate each and every. I posted it. You will have 2 recorded videos under recorded labs, okay, by me and another TA. So you can watch any one of them. Okay, here I have already posted this document. This is for lab 7. So it will walk you through how to do this. You can also watch the video, or you can just go through this. Now this is a categorical variable. I have plotted histogram only for one variable. Okay. Now, how do you check whether confidence interval is valid or not? So here, if you can see under frequencies, the count that gives you the sample size of a female and male. Okay. So we are supposed to multiply the 66 and the probability corresponding to that is 0.5. So when you multiply those two, if you get more than 5, then we say confidence interval is valid. So you will have many variables to do. So what I do was, if the count is greater than 5, then we can easily say that NP will definitely be greater than 5. Okay, so I do that. So you can just go through the count, and each count is greater than 5, you can say it is valid. You will have a few variables where it will not be greater than 5, and you will have sometimes you will have like female might be 3, male might be 5. So one is valid, one is not valid. So you have to mention that in the table. Okay, like this. you have to create a table like this. Variables, confidence interval, valid or not. You have to say why it is valid or why it is not valid. Okay. Now this is the starting 5 is for categorical, and this is how the table will look. Okay. And this is for the part 2. Fine. And for question number 4 and 5, you can just report. So you can watch the video or you can go through this document. It is easy. Okay, so that was about chapter 7. So next is chapter 8, basics of hypothesis testing. Now, what is a hypothesis? So in simple words, for example, say that you have experimented a medicine which will cure the headache. Okay, you have done that. Now, if someone repeats the same experiment, it has to give the same result. So if it is not giving you the same result when it is experimented again by the another person, then your research is not considered, right? Now, to find out that, we use hypothesis. Okay, now in simple words, to say it is nothing but a guess about something. It could be anything. Guess about something, and it should be proved by experiment or observation. By experiment or might be by observation. Say you find out a vaccine for COVID-19, and if you guess that it will work, it will cure, then you have to prove that by experiment or observation. Okay, so that's the simple definition of hypothesis. Now, what is hypothesis test? If you're testing the claim, so whatever you say or whatever you guess in your hypothesis, that is called as claim. Okay, so if you're testing your claim, then that is called as hypothesis test. It could be through experiment or observation. So if you are doing that, it is called as hypothesis test. Okay. Now, in hypothesis, we have two types: null hypothesis and alternative hypothesis. Okay, so null hypothesis is denoted by H0, and alternative hypothesis we usually denote by H1. Or maybe HA, but we usually use H1 more often. Okay, so what is null hypothesis? Very simple. If an hypothesis, if the value of a population parameter, if it is equal to the claimed value. For example, I will guess that a population mean is 5. And even after experimenting it, if you get population mean as 4.9, then I say null hypothesis. Okay, accept the null hypothesis. Okay. Now this sign. So we generally use equal to sign for null hypothesis. Equal to. Only this sign. Okay. So this is in your lab 8. Now, what is alternative hypothesis? If the parameter value is not equal to what you thought, what you have claiming, then it is alternative hypothesis. Very simple. Now you will be denoting alternative hypothesis using the below symbol: less than, equal, or not equal. So less than, greater than, or not equal. Okay. Null hypothesis equal to, alternative hypothesis less than, equal, less than, greater, not equal. Okay, null hypothesis has only one sign, equal to. Alternative hypothesis has 3 signs. Okay, remember this. Now, let's do one example. Okay, They say that this is the claim they are doing. Now they are saying that the mean value is at least 100. That means it should be greater than or equal to 100. That is the claim given in the question. Now you have to write the null hypothesis and the alternative hypothesis for this. Now I told you that null hypothesis is represented by H naught. This is null hypothesis. Now how do you write null hypothesis? With equal sign, equal to 100. Okay. Now next is H1. H1 is the alternative hypothesis. Now for H1 we have three signs: less than, greater than, or equal to, or not equal to, right? Now how do you choose this sign? To choose that, you have to observe this value. If the claim is greater, then you will say alternative is less. Fine. You will not say equal to, never, because alternative can be less, greater, or not equal to. It cannot be equal to. If it is equal, then it is null hypothesis. So this is how you write the null hypothesis and alternative hypothesis. Okay, very simple. Now I want you to answer B, C, and D. Similar to example A. Just write what is the claim and null hypothesis and alternative hypothesis. What will be H1 for C? Any guess? Not equal to. You had a question? Claim is P equal to, it's not equal to 60%. Then H naught is P equal to 60%. And H1 will be P. Any answer for this? D. So when we have this type of question, okay, so here only exception is if your claim is greater than, we use alternative hypothesis as less than. If your claim is less than, we use alternative hypothesis as greater than. Okay. Now, if it is equal to, then we say H1 is not equal, right? But if your claim is not equal to, then you cannot write H1 as equal to, because that will be your null hypothesis. So we will keep it as it is. Okay, this is the only exception. So just check your answers. It has to be this. Yes, null hypothesis will always be equal to sign. Okay. Okay. Now, example 2, you just have to fill this. Now you know what is A, B, C, D. Fill the claim, null hypothesis, and the alternative hypothesis. Okay, you have already done the previous example. New. Okay. So next is a type of test. So we have three types: two-tailed test, left tail, and right tail. So when do we call this? Now, if you can see this table, so if your H1, that is your alternative hypothesis, if that consists of this symbol that is not equal to, then we call it as two-tailed. So why is that? Now, for H1 not equal to, your normal distribution looks something like this. Okay, so it will have two tail. That means it will have two areas under the tail. Okay, now if your H1 is less than, that means it is left tailed. That is, the values will be here. okay, towards the left. So you will not have any values towards the right tail. You have only towards the left tail. So then that is called as a left tail test. Likewise, if your null hypothesis, the alternative hypothesis, if it is greater than, then your values will be towards the right tail. So it is called right-tailed test. Okay, we will learn about the critical region. Now the P which is mentioned there is nothing but the values which is given, which you are claiming. Okay, and we will see what is K also. Okay, now what is a critical region? Okay, now critical region is nothing but the region or the area under, say, I'll write it here. Now, if you can see here, these areas, okay, I'm talking about the areas, okay, the region, the shaded region. So those regions are called as critical region. So we call that because at that point we are going to reject the null hypothesis. So if you're rejecting the null hypothesis, that area, the region where you're going to reject the null hypothesis is called as critical region or rejection region. So you will understand this completely if you do one example. Okay. And likewise, we have alpha. So we know that from the previous chapters, alpha was the area under the curve. Alpha was called as area under the curve. Now, in hypothesis testing, we call this as significance level. Like we have confidence level, in hypothesis testing, we have significance level and it is denoted by alpha. So here, it will be area under the tails or at the tails. Okay, so this alpha significance level will act as cutoff. That means you must be having some values greater than that or less than that. So you will make decision based on that. Okay, if it is greater, then you will say whether it is reject or accept the null hypothesis, like that. Okay, so we will see some example on that. Okay, so here CV means critical value. Okay, CV means critical value, and we have one more TS, that is test statistic. We will see that later. Okay, now example 3, you're going to find the critical Z values, and they are just giving you the name of the test and the value of alpha. Okay, now when you have a two-tailed test, what does that mean? Your normal distribution looks something like this, right? You have area under each tail. So here alpha was 0.025. Remember from the previous chapter, 0.025. Now, if your alpha is 0.01, how did you get this? This was alpha by 2, this was alpha by 2. So you are supposed to find Z alpha by 2. Okay, Z 0.01 by 2. If you have two-tailed, you will be calculating like this. Z alpha by 2. Value will be Z 0.005 will be equal to 2.58. Now this could be positive or negative, so I'll just mark it as positive or negative. Now, even if you calculate negative z 0.005, you will be getting negative 2.58. So I'll just write like this. You will have the same value, but different sign. So if you have a two-tailed test, you're going to find z alpha by 2, like you did in the previous chapters. Use inverse norm, you have the area, and find out what is z alpha by 2. Okay? So if you have a left tail test, that means only one tail. Okay? Now, if you have one tail, that means you're going to find only z alpha. So use inverse norm in your calculator, inverse norm of the area 1 minus 0.005. Okay. You don't have to use mean and standard deviation to z-square. So if you do this, you will be getting 2.58. So since it is on either side, only difference will be in the signs, not the value. So you will be getting this. Okay. Now for left tail test, you will be calculating z alpha, that is z 0.05. And this would be only one value, one side. Yes, you will be getting a negative value. So the answer for B will be minus 1.64. You just have to use inverse norm of the area and you will get negative 1.64. Okay. Now for question C, you have alpha value, but they have not mentioned which test they are using. So how do you find that? We use 0.05. Why? Because we are using only one tail. So if you are using two tail, that means you have two alphas. That means you are going to divide by alpha by 2. So you have one area given. So you are going to divide it by two sides. Now if you have only one side and one area, you are going to give that area to the one side. Right. Okay. So for question C, they have not mentioned the test, but they have mentioned the sign here. Now if it is greater than, then it is a right tail. Okay, so this information is given in this table here. If it is greater than, it is going to be a right tail test. Now option C is right tail test. Okay, so you will find z alpha, that is 0.10, equal to what? Just use inverse norm and find the area. If it is to the right side, you have to minus it by 1. Okay, and for option D, for the question D, so you have given P not equal to 0.20. So if it is equal to or not equal to, it is going to be a two-tailed. You will have two tails. So you are supposed to find Z alpha by 2, that is Z 0.05 by 2. Now this is going to be plus or minus because on either side. Okay. So if you have done this, this is going to be 1.28 out. You're just going to use inverse norm of the area 0.10. Okay, in your calculator. Now here, this value is going to be plus or minus 1.96. You will be using inverse norm of 1 minus 0.025. Okay, 0.05. Inverse norm, inverse norm. So that's how you calculate the critical value. So if you have equal to or not equal to, it is going to be a two-tailed. So if it is a two-tail, you will be calculating Z alpha by 2, and you will have two signs, plus and minus. Okay, now if you have a left tail, that means it is less than. Alternative hypothesis is less than. So you will be finding only Z alpha and you will have one sign. Okay, likewise for right tail, you will be calculating Z alpha, you will have one sign, and it is alternative hypothesis is greater than. Okay, now I know this is a lot to take, but if you can prepare a table or some notes, you can easily understand. Okay. Now next is test statistics. So this is a value like your z-score or like a critical value. Okay, now how do you find this? Now I guess there should be. So in this table you will have two more, that is t-square and one more distribution, but maybe it is there in the section 8.2. Okay, so here in test statistics, what we are going to do is we are going to convert the sample statistics, that is the p, cap, the mean and the standard deviation. We are just going to convert that to a scores, like z-score, x-score, or t-score, or x square. So this square is nothing but called as t-square for variance. Since it is a square, we call that as t-square for variance. So we will study about that later. Now, coming back to the table here. Now, if a proportion is given, or if you are claiming for a proportion, then it is going to be a sampling distribution or a normal distribution. And the requirements are the successes and failures must be greater than 5 or at least 5. Okay. Remember I told you n into p should be greater than 5 for the lab 7. Yeah. Now, if those requirements are satisfied, then you're going to find the test statistic using the formula given in the table. Okay. Now, if you're doing for mean, if you are claiming for the mean value and you have a t distribution, that is sigma is not known. So the only difference between normal distribution and t distribution is standard deviation of that distribution is not known. If it is not known, that is a t distribution. Now this is the formula for that. Okay, so you have two more formulas I will be explaining to you on in the section 8.8. Okay, so we will do one example. Finding, so this is for finding TS. Now I will call test statistic as TS and critical value as CV. Okay, so what is a claim? Claim is the proportion, I'll just denote it by P. They're saying that it is different. Read the question that they say that the proportion of drivers are different. They did not mention whether it is greater than or the less than. Now they are just saying it is different. So if it is different, I will be taking it as not equal to. So it is not equal to the reported value, but it is something different. So not equal to 10.3%, or you can say 0.103. Okay. Now you have the claim, write the null and alternative hypothesis. No. No. So P is not greater than because they have not mentioned it anywhere. They're just going to say it is different. Now different means it could be less, it could be greater. Now if you claim it is greater, then you're wrong. So there are chances it is less than. So it is safe for us to say it is not equal to. So even if it is greater or less, so equal to will satisfy both the conditions, right? So this is your null and alternative hypothesis. Now what is En? N is equal to 800. It is given in the question. Now what is P hat? P hat is 12%, 0.12. P hat is sample population, sample proportion. Okay. Now we need to find test statistic. We have two formulas. Which formula do you choose? The first one? How many say first one? Okay. Why is that? Yeah, right. So we are not looking at the mean, we are looking only on the proportion P. So we are supposed to use Z equal to P cap minus P divided by square root of P into Q divided by N. Now you have all the values, just plug in and find the final answer. You mean the P cap? So yeah, regular P will be 0.103. You must be getting z-score as 1.58. Okay. So next is, sorry. Oh, yes. So it is going to be 1 minus 0.103. Thank you.
So the P is the same thing as the P cap?
No, P cap is different and P is different. So P cap
Okay,
is this.
because like where it says the point 12, isn't that the P cap?
So 0.12 is the P cap
Okay, so
and
then on the
capital
bottom on the
P
square
will
root.
be 0.103.
Okay, so but that's where I'm confused on the bottom where it's saying 0.12 times the 1 minus 1.03. So
Yours.
mhm. I'm
Okay.
wondering
So
why
how
the
do you
0.12 is there.
find Q when P is given? If you have P, then Q will be 1 minus P. So you don't use P cap for that.
Okay,
If they are asking you to find Q cap, then it is 1 minus P cap. If they are just asking you to find Q, then it is 1 minus P.
okay. Okay, thank you.
Indeed, yes. I had a flu shot in the morning. Okay. Next is p-value, and p-value here is also called as area. Now, for area, you had two notations. One was alpha, and now you have p, right? Both are called as area. Now, what is the difference? So this is area for C square, and this is the area for TS, test statistics. So let me put this. Okay, if you have a critical region, then that area is denoted by alpha. If you have a z-score with a test statistic, then that area is called as p-value. That area will give you the p-value. So p is nothing but the probability. So you will have lab 8 mainly on this. You have to identify the p-value and check the claim. You have to test whether it is reject or accept, fail to reject the hypothesis, null hypothesis. Okay. So we have few more to do. So we will do this on Friday. Yeah, we finished till example 4, and now we will study about p-value. So p-value is nothing but like your alpha, the area under the curve. Now we use alpha when we have a z-score or a critical value. We find p-value, which is the area again. So this is also for a z-score, but that z-score has to be found using the test statistic. So if you have an area related to the critical value, it is denoted by alpha. If you have an area uh, related to TS, that is test statistic, that will be your p-value. Okay. So let us do some examples. Now you can find the p-value using a normal CDF. Okay, all you have to do is to find the z-score, and then you can put the z-score in the normal CDF. You know how to do that. We used it in the previous class. And then you can find the p-value. P-value in the sense, the area. Okay. Okay, so let's do some example here. Now, z is given. Z is already given. You don't have to find that. Now, we know it is test statistic because it is given here. And it is a z-score with minus 1.74. Now, you will apply normal CDF. Normal CDF. Since it is a left-tailed, so left-tailed, your lower will be minus 999 and upper will be negative 1.72 and your p-value will be equal to 0.0447. You have to do this in the calculator and check whether it is correct or not. Okay, for question B, you have test statistic. Z is given 1.63 and normal CDF minus 9999 and you have the z-score here, p-value okay, and for the third one it is a test statistic. You have a z-score of 1.90. I did a mistake here. You see it is a two-tailed. So if it is one or left-tailed, you will have this here. Okay, now if it is a two-tailed, only difference will be here. So you are going to multiply p-value with 0.0516 and p-value will be 0.103 if it is a two-tailed. Now you have z-score given, but the test is not specified, so they say it is greater. So if it is greater, what is the test? So we'll go back to the table. Now it is greater. If it is greater, it is right tail. So you can say it is a right tail. Okay. So you will use normal CDF. Now you will change the limits. You have upper value as 1.900 z-score, and you do not know the you have lower limit and upper limit. So you do not know the upper value, so you will just enter it as 99.99. Now your p-value for this will be 0.0287. Okay, you're not going to multiply it by 2 because it is greater than right tail, so only change is in the value. Okay, so that is how you find the p-value. Now you can also do this using GMP, and you will be learning that in your lab 8. Okay, now you know how to find the H naught, the null hypothesis, the alternative hypothesis, and you know how to find the p-value. Now using that, you need to make a conclusion, right? Because you are doing some claim and you need to conclude whether it is acceptable or not. Okay, now we will see when we have to reject or when do we fail to reject the null hypothesis. Okay. So if a p-value which you get, if that is less than or equal to alpha. So what is alpha? It is a significance level, right? So if it is less than or equal to alpha, we say reject H naught. If p-value is greater than alpha, we fail to reject null hypothesis. Okay, so this is how you make the conclusion. Okay. Now we will see this using some example. We will say whether how to make a conclusion. Okay. So I'll tell you how to do this, and you can do at home. Now, to conclude the initial conclusion, to write the initial conclusion, you have two options. You need to compare the CV and TS, that is score, and you need to compare, in option 2, you need to compare the p-value and the alpha. Okay. Now, how do we do this? Now, here, you need to find the p-value. Z-score is given. Find the p-value. So, which Z-score do you use? You use the statistic Z is equal to 1.45. Okay. Now, find the alpha. How? Using CV. Z is equal to 1.23. Okay. Now, for both of them, you use normal CDF. And you know how to do this. So, this is a right tail. Okay, we have done few examples here. Follow the same thing and you will find P and alpha. Now you're going to compare P, alpha, and then you will conclude. So if your p-value is less than or equal to alpha, you reject the null hypothesis. Okay, so this is what you have to identify. This is what. Okay, likewise you will be doing this and this. Now to do this, you don't have to find the P and alpha, you just have to compare. So here the p-value is this, less than or equal to alpha. Now 0.23 is the p-value, less than or equal to 0.0. 0.23 is not less than 0.03, so you fail to reject what? H naught. Okay, you have p-value, you have alpha, you just have to compare. Now this is how you will write the final conclusion. So this is more often how you can write in the words. Okay, so this you will be doing in your lab 8 also. Now let's see how to do this. Now the example, the claim is the p, the proportion, is less than 0.27, right? I will write the claim first. Claim is what? 0.27. Okay, so I will say H naught is P equal to 0.27. So we have null hypothesis and alternate hypothesis is H1. So since it is less than, so this is the original claim. So you can follow the original claim. So it is less than 0.27. Now, initial conclusion is rejecting the null hypothesis. Now, how can you write this as a final conclusion? Now, you can use this table and you can write the conclusion. So here you can write there is sufficient evidence to support the claim that the proportion of college graduates who smoke is less than 0.27. Okay, this is how you will be concluding. So according to initial conclusion, you're going to reject the null hypothesis. And how do you write that in the final conclusion? Use this table. Now here there is a sufficient evidence to support the claim. That means you're going to reject the null hypothesis. So you'll be using this. Okay. Right. Now we will see another example. So we have null hypothesis like this, p equal to 0.05, and we have h1. It is saying it is greater than, so it is p greater than 0.05. So this is the original claim. So if it is greater than, it is a right tail. Right-tailed test. So they have not given you the initial conclusion. So let's do that. So initial conclusion is fail to reject, we'll see why. Fail to reject H0 because the p-value is greater than alpha, right? The p-value is 0.06. How do I know that? P-value here is 0.06. So let me write it as p-value. Okay. So 0.06 is definitely greater than alpha. So this will be your alpha. So since it is greater, we are going to write it as fail to reject null hypothesis. Okay. Now, how do you write this in the final conclusion? So your final conclusion will be like this. There is, since you are saying that fail to reject, there is insufficient evidence support the claim. Simple. Okay, so that's it. So this is how you write the final and initial conclusion. Now, here you have some content, so you can refer this, you can read this on your own. So this will help you when you're doing your MLM assignments. Okay, so that was about initial and final conclusion. So here we will learn about errors. So basically we have two types of errors, type 1 and type 2. So when do we say it is a type 1 error? So when you have H0 true, that is the null hypothesis is true, but by accidentally or by mistake, if you are saying that if you are rejecting the null hypothesis, then we say it is a type 1 error and we represent that by alpha. Okay, so type 2 error, if the null hypothesis is false, but you accept the null hypothesis, then it is a type 2 error. Okay, so it is denoted by beta. We call this as beta. Now we have a table here. So if you are rejecting null hypothesis, but the null hypothesis is true, So it is a type 1 error. So if you are rejecting null hypothesis and yes, the null hypothesis is false, you made a correct decision. Likewise, if you are doing fail to reject null hypothesis and if the null hypothesis is true, so this is nothing but, in simple words, you are saying null hypothesis is true. So if both are correct, then you made a correct decision. There is no error. But if the null hypothesis is true, but you are saying it as false, then that is type 2 error. Okay, so this is how you identify type 1 and type 2 error. So we have two examples on this and we will see how to identify the type 1 and type 2. So for the first example, we will write the null hypothesis p equal to 0.1. So your null hypothesis not equal to 0.1. Now type 1 error, how do you write? Okay, so you will write like this. You are going to reject the null hypothesis, reject the null hypothesis that, so what is the hypothesis given? That the proportion of people who write with their left hand is equal to 0.1. And also the proportion is, when the proportion is 0.1. Okay, type 2 error. How do you write this? So you will say fail to reject the null hypothesis. I will denote it by H naught. But what is the claim? The claim is that proportion of people who write with the left hand is equal to 0.1. That's the claim. But according to type 2 error, the proportion will be not equal to 0.1, or say it is different from the 0.1. It could be greater or it could be less. Okay, so this is how you write type 1 and type 2 error. Now, for the second example, H naught is P equal to 0.5, then your alternative hypothesis will be greater than 0.5. Okay, now how do you write type 1? You say reject null hypothesis. And what's the claim? That the proportion of female students is equal to 0.5. That's your type 1 error. But actually the proportion given here okay, that's type 1, and type 2 will be fail to reject null hypothesis that the proportion of female students is equal to 0.5, but the proportion is what? Well, the proportion is greater than 0.5. Okay, so this is how you write the pattern. So this will complete your section 8.1. I'll be posting this in the Blackboard. Go through the video and go through the notes, so you can ask me if you have any questions on Friday.